Hey grade 12s, so let's continue from where we stopped. So I decided to do another video and merge it with the previous one so that it's all in one video. I just don't like too many videos for the same thing. Now folks, we did our question 18 and we finished, so we were supposed to start question 19. Now question 19 says, in the diagram alongside H, E, N, and G lie on the circle with center O. So these are concyclic points, and we can appreciate already that we actually have a cyclic quad already formed. Now NC is a tangent, so this is great to know that this is a tangent. Wena man siniphaphela wena man. Iyakuthanda ukungiqhela kakubi ke le nto. Yo hayi asiyeke yaniphambanela izawuniphambanisa. Right. If this is a tangent, guys, you already know that this angle is going to be equal to that angle. Tan chord theorem. Okay, so no questions about it. And then we've got B lies on HC and GB is parallel to NC. So there's GB parallel to NC. And again, we're going to have alternate angles happening there. So this piece already confirms that this side is equal to that side, because those equal chords are subtending equal angles at circumference, or one can say these are angles opposite the equal sides in triangle GNE. All right, so essentially, guys, we know that this very angle that we looked at basically gets doubled here, isn't it? Okay, maybe doch. All right, so we got it, guys. It's just irritating me at the moment, this tablet, but I feel like it's gonna mess up everything. But all we should know is that this angle is going to be half. Maybe let's just do that. It's gonna be half of the angle at center, because angle at center is twice angle at circumference. Okay, so that's the story. So this means this angle is also going to be x, and that means that angle is also x, essentially. All right, so that's what we have. Now what else? We're told that HG is equal to HE. So if that's the case, it already confirms that the sum of these two angles, G3 and G2, maybe let's just make this bigger. So we can see that G2 and G3 must be equal to this one over here. Right, again, we can look at these as angles opposite, or should we say angles subtended by equal chords, or angles opposite equal sides in that triangle. Right, and now we're told that GON is 2x. We already saw it. Now let's get to the proofs. So we're going to have 19.1. Right, now what are we supposed to prove? That GN is equal to NE. So we already did it from our analysis. So the first thing that we're going to say is that, how do we start? We're going to start by saying E2 is equal to N3. What is that? These are alternate angles with GB parallel to NC. Right? That's good. But we know also that essentially G1 is equal to n3. This is the 10-chord theorem. Right, so this makes a nice conclusion that, well, E2 should be equal to G1. That's what we want. So each one is equal to N3. So N3 is the link. So if this is the case, so what can we conclude? If those two angles are equal, so we can easily say, therefore, GN is definitely equal to NE. Now here we can just say equal chords subtend equal angles, or these are chords subtending equal angles, or we can just say these are the sides opposite equal angles in triangle GNE. Maybe that's much easier. So we are done. So sometimes we'll see a lot of marks for something that is really nothing. So this means statement and reason gets a mark. Statement and reason gets a mark. That conclusion, and of course the reason for the final answer. Otherwise, could easily have been just 3 marks, maybe 4 at the very least. Right, 19.2 says, we need to prove that GON is similar to GHE. Ooh, what a mess. Okay, let's have a look at them. So what we see there, we're comparing those two triangles. So how do they compare? Right. We need to think about it a little bit because it's not so obvious at the moment. Okay, so obviously if this is 2x, then it means this angle here is going to be 90 degrees minus x, isn't it? As well as G1 plus 2. But now our sketch is too small for us to do anything about it in that manner. So we don't want to end up with a nightmare. I just want to know, what do I do? What do I do? Oh yeah, if I look at this angle is 90 degrees, right? That angle is 90 degrees. But again, this one will also be 90 degrees. These are corresponding angles. So this means this side is cut into 2 equal parts as well. All right, does it help me with anything? As I'm looking at it, it's not really helping me much, but maybe it does, because then it tells me that this angle is going to be 90 degrees minus x, okay? Yeah, I think it's going to help. And then this one also is going to be 90 degrees minus x, isn't it? Because we know that from that isosceles triangle, the green one, that would be 90 minus x. Now this will help me to combine this angle to parachute into this angle, because those are opposite angles of a cyclic quad. So that can help me to get to that. Then from there, since it's an isosceles triangle, so it can work, but it's a bit silly how it's going to work. But anyway, let's start by saying, well, these are ready. We know that, right? We need to say that. This is quite complex, the way I look at it. I mean, I feel like the one for 6 marks is that question than the first one. Unless I'm missing something, which I doubt. Anyway, let's go for what we know, folks. We're going to say, well, in triangle GON and triangle, what was that? GHE. Okay. Right. So what do we want to say? Well, we want to say, so now we're going to have to work with one triangle, then link them up later on, because I don't see any other way. So I'm going to say, well, I know that N1 is equal to NGO, whatever this is. I know that these are angles opposite equal sides with ready, I don't want to say too much, OG equal to ON. That's as simple as that. I'm talking about this triangle GON. So what do I want to do? This implies that N1 plus NGO, right, plus GON, this should be equal to 180 degrees. So this implies that N1 plus this NGO is essentially the same. You can just write N1 plus 2x equals 180 degrees. I'm going to jump for the jugular, guys. N1 is going to be 180 minus 2x divided by 2, which is going to give me 90 degrees minus x. Okay, so you can already see what happened here. If you did not, then go for it. Step by step, you will end up there. So that's the first thing. Yeah, this question is crazy, guys. It's really crazy. Anyway, I'm going to also say, I know that x, or maybe let's say this, I know that N3, right, plus N2 should be 90 degrees. This is the tangent perpendicular to radius. All right. Now N3 is x plus N2 equals 90 degrees. Therefore, N2 is equal to 90 degrees minus x. So this is now getting that whole angle. I will say, but I know that angle H plus, let's say H2, plus GN E is equal to 180 degrees. These are opposite angles of a cyclic quad. At least there's only one so far. We can leave it at that. So this implies that H2 plus this one is going to be 2 times 90 degrees minus x is equal to 180 degrees. So essentially, guys, I'm moving fast because we saw that GNE is going to be N1 as well as N2. So that's why I'm just doubling it. Sometimes you need to be quick and fast. So that means H2 is going to be, this is going to be 180. 180 goes away. 2x transposed is just going to be 2x. So that's good. So first of all, we now know that the other two angles are equal. And since these are both isosceles triangles, the angles are also going to be equal. We don't need to do that. So we can say, therefore, we appreciate that essentially GON, or whatever GNO, angle yapa, this is GON is equal to H2, right? If this is the case, we can easily say, therefore, triangle, I'm not going to waste time here, guys, triangle GON is indeed similar to triangle GHE. At this point, These are isosceles triangles with just one angle equal, then the rest are going to be equal. I don't know if this is allowed or legal, but I feel overwhelmed already. For 5 marks, icon. Now I'm going to say here, or maybe we should, what can I say, guys? Yeah, but if we prove this, maybe we need to say more. We can easily say, therefore, let's just say something about the other two angles. We can easily say, therefore, N1 should be equal to E1. Now we can just say these are the corresponding angles of isosceles triangles. Yeah, I don't know, guys. This is crazy. Corresponding angles of isosceles triangles. Ay. Anzange ndayibona, but I feel like it's overwhelming me. If I'm gonna go through it step by step, we can easily make a conclusion that therefore this GON is similar to triangle GHE. K angle, whatever. It's done, guys. Ridiculous as it is, some questions are not nice because they make you, sweat. Isosceles triangles, when you want to prove similarities, are the worst, because to plan this is just not so nice. Anyway, we got it, boys and girls, ladies and gentlemen. So we're going to say 1 mark for this. We are happy, and maybe 1 mark for that. The statement and reason, important. We're not going to care about this. The statement is good. Do you see what is happening right now? Injalo, guys. And there's nothing I can do about it, eh? Alright, we have 5 marks. However, guys, these marks are given. The question is already irritating. Yes, there's nothing you can do about it either. So we've got 19.3. So 19.2 was not a very good question. Now let's have a look. We've got 3 marks. So what happens here? We need to prove ON. Remember, guys, we locate these. Where is ON? ON is inside here, right? And where is GE? GE is over here. Okay? So that's GE. No, lying. GE is this side. Oopsie. Right, so we can see that. Now, what is this GN business right now? Where is GN? GN is over here. Okay, good. So what are we looking at, guys? Already from this business, I can already see that I'm dealing with the sides of the green triangle and the blue triangle. Now let's look at this one. Where is this? HB. So HB is over here, and then EP is over there, and then BC is over here. So this again is trying to tell us something that, okay, after we've used our green triangles, we're probably going to have to zoom into this one. We're going to zoom into this triangle. Right. So we can see that the proportionality theorem is doing its own things too. So we're going to have to apply our proportionality theorem here, because we can see those sides, and this side is somewhat common. Okay, so let's start. Now, once you see these 3 things and 3 things, it means we chose a side that perhaps is common. And I think the side that we are using is HE, because HE is somewhat going to give us some common stuff. If we use proportionality theorem in the shaded triangle, and we use the similarity of these two triangles, the blue and the green. Unfortunately, the sketch is a bit busy, but I think I tried to annotate it in such a way that you still see what needs to be seen. So we know, folks, that, well, we have ON here. So I'm going to use ON over. Now ON is opposite that angle, okay? Now this angle is equal to which other angle? Well, we can say is equal to that angle, or if we like, we can say that angle, right? But let's use that angle. Say this is going to be over HE equal to, now what else do we want? GE to come out. So GE will come out when we use GN. So this is going to be GN over, of course, GN is opposite that angle is equal to that, which gives us GE, okay? You can just say similar triangles in 19.2. So we know that. Now we want to make something the subject. If we cross multiply and isolate HE, since we can see HE will link us into the two triangles, you can just say therefore HE is going to be ON times GE divided by GN. All right, so that's good. So we already have that one. You can say also, we know, folks, that HE over EP should be the same as HB over BC. This is the proportionality theorem with EB parallel to PC in triangle HPC. I didn't want to say in triangle this and that. Sometimes just make the reason make sense. Now again, folks, if we look for HE, we can say therefore HE is going to be HB times EP all divided by BC. Now we can see that this spells out HE as well. So those two are equal. So therefore ON times GE divided by GN is equal to HB times EP over BC. Proven. Okay, so again, simultaneous equations technique, knowing how to look at the sketch. So how many marks are we scoring here? Just 3. Okay, that statement and reason is good. I think that statement and reason is good. And of course, equating the two was the final finish, although the answer was given, but we had to find it. Good stuff. So again, it's not a very nice question for the 19.2 part. I think the marks were misplaced here. The first one should have been 5, the second one 6. But anyway, the people who compile these sometimes make a nightmare of an easy situation. So this would have been 14 marks. And we smile our way forward. All right, guys, we need to finish now. I'm tired of this Euclidean geometry business. Right, in the diagram alongside, a circle is drawn passing through A, B, C, and D. And we can see it's a cyclic quad already. BED is theta, so there it is. BE and ED are tangents. So if they are tangents from the same point outside the circle, they're going to be equal in length. Yes. Now prove that BCD, this angle, we need to prove that this is 90 degrees minus theta. Okay, is that so? We shall find out. 6 marks, not 90 degrees, but over 2. Okay, so let's see. What must we do here? Okay, so this is the angle that we need to find out stuff about. All right. Well, looking at this, we need a construction. I think a construction is going to help us. If we draw this diagonal, we stand a chance of getting somewhere. So sometimes you're going to get a construction, especially in a question that is not so busy like this. Once it's less busy, just know a construction is somewhat needed. So don't be afraid to do a construction when you can, especially in an empty, a ghost town like this needs construction. All right, so let's get to business, guys. Question 20. Now, what do we say here? We're going to say draw DB. Nice and easy. So what do we end up with, guys? Now we end up with nice things. This angle is going to be equal to that angle. 10 chord theorem equal to that angle. No. Equal to that angle. 10 chord theorem. And we can easily say these are angles. What do you call this? These are going to be angles opposite equal sides. Then we use 10 chord theorem. After the 10 chord, we are going to use our cyclic quad. Because after that, we're going to have to utilize this cyclic quad. You know, we're going to have to use it. It's going to come to our rescue. Because we are going to take this angle and add the other angle, and they should be supplementary. That should bring us to something like that. All right, so let's start, of course, guys. We're going to say, well, in triangle DEB, Debbie, or bed. Right, what do we know? We know that DE is equal to EB. These are tangents from the same point. Okay, so that's done. And we can say this implies that basically angle EDB is going to be equal to EBD. Right. So these are angles opposite. Angles opposite equal sides. Right. Now, what do we want to say? We are going to say also, we know that now EDB plus EBD plus angle E should give us 180 degrees. This is the sum of 3 angles of a triangle. We're still talking about that same triangle. Now we can choose any that we like. I'm going to choose EDB. So this is going to be 2 times EDB, because those are equal, plus theta equals 180 degrees. So that means angle EDB is going to be 180 degrees minus theta divided by 2. Maybe let's not rush. Let's not rush. So we can say, therefore, EDB is going to be 90 degrees minus theta over 2. Right, so that's the angle. We will say here, but what do we know? We know that basically angle, that A is strange. Angle A is equal to angle EDB. Why? This is the tan chord theorem. Okay, so therefore angle A is basically 90 degrees minus theta over 2. Cool. We will say then, we know that angle A plus angle C, maybe let's write it the way it was mentioned, angle BCD, we should get 180. These are the opposite angles of a cyclic quad. There's only one so far, so we don't need to fuss about which one. So A is 90 degrees minus theta over 2 plus BCD equals 180. So from here we know that BCD is going to be 180 minus 90 is 90 degrees. We transpose that, it becomes theta over 2. Done. Sometimes they may not give you the answer. They'll just say express BCD in terms of theta. And you sweat. Okay. Again, this is one of those essay type questions which can be a standalone question. So 6 marks, statement and reason. I think that's the main thing. And this becomes another thing. Statement and reason. Statement and reason. The substitution. Substitution. 1, 2, 3, 4, 5. Okay. We can say 6 just to give it. It's easy. Easy 6 marks. You just have to be patient with the process. Alright guys, I'm doing this in the hopes that you are going to start to see how to go about these problems. Remember, if you don't do this by yourself, it's never going to click, okay? And if you don't struggle while doing it, you're never gonna master it, okay? Just remember that. You only will need luck in the exam to find easy ones. But if you don't, then you're not gonna make it, okay? But usually Euclidean geometry has been made easy lately. They make it just hard on one question or so. The rest usually is easy, standard grade, so I don't see why you guys should struggle. We had it hard. I mean, look at that exam paper that I did, which I wrote myself in the finals. You will see that there were stones. There were no easy questions. The easiest was proving the theorem. The rest, you didn't get it so easy. It was a jiggy. But yours, guys, I could pay nothing. It's just one question which is going to horrify you. The rest is just easy stuff, okay? So remember this. So if you want that distinction, your Euclidean geometry has to be proper. Okay, let's do the other one. It's not the last one. There's 2 more. Now, this one says, in the diagram below, A, B, C, and E are points on the circle. What do we call points on the circle? Yes, you had that right. This is concyclic, meaning any 4 of them would form a cyclic quad. But in this case, even if it's not, we see a bow tie. Immediately, this angle is equal to that angle. Angles in the same segment subtended by chord AE or arc AE. Quick guys, this one is going to be equal to that one. Again, Those are angles in the same segment subtended by arc BC this time because there's no chord. All right, AC and BE intersect at F. Those are straight lines. Once you see this naming, it's already highlighting that we are dealing with straight lines. Okay, so be familiar with the way we name things. D is a point outside the circle. CD and DE are drawn again. Those are nice straight lines. Cool. So what are we going to do about this? We are told that ABE is X. So this is X. So this makes that angle X. Then BEC is Y. So that also makes that angle Y. And then CDE is theta. It's indicated, okay? Now we are told that if theta is equal to X plus Y, then prove that FCDE is a cyclic quadrilateral. Okay, let's see. Okay, so we need to prove that to be the cyclic quadrilateral. All right. Now, this is nice because if we look at this triangle, if we look at this triangle, guys, what are we going to see? We see wonderful things, don't we? We see beautiful things. Do you see that this triangle automatically, of course, if we have to, because remember, this is the angle that we were given originally, and that's the angle that we were given originally. So if we just push this one in there, you see that the exterior angle of that triangle must then show up to be equal to this, so that we can say exterior angle of a cyclic quad. So we've got it in the bag. So we know that 21.1 says, fine, we're going to say in triangle ABF. What do we see there? We know that A1, in fact, let's start here. We are going to say B is equal to X. That was given. All right. Nice. We say here A1 is going to be equal to E2, which is also going to be equal to Y. Now, what is the story here? These are angles in the same segment. Okay, good. See, Kabil, we can say then, or we can say, what are we going to say? We're going to say, this time around, I'm tired. So we know, guys, that B4 is going to be equal to A1 plus, maybe let's start with B. It's going to be equal to B plus A1. What is this? Exterior angle of a triangle. Nice and easy. Therefore, B4 is equal to, maybe we can put some nice opening statements, but that means B4 is going to be X plus Y. We can say now, since we were told that CDE, or perhaps let's just say since theta is equal to X plus Y, this confirms for us that B4 is equal to CDE. Ne? And if this is the case, what are we going to say? We can say, therefore, this FCDE is a cyclic quad. Now we've used the converse of exterior angle of cyclic quad. So easy stuff. Remember, we normally say the exterior angle of a cyclic quad equals the opposite interior angle. Now we bumped into the information that the angle interior is equal to the angle exterior. Therefore, it confirms that we are dealing with a cyclic quad. Good stuff. So, easy 5 marks to score here. I think that statement and a reason is important. This is important to link these two. That answer, maybe that statement too. Easy 5 marks. We move. Oh, there's more. Okay, there's more. So there's 21.2. 21.2 says if AB is equal to AE, then prove that line AE is a tangent to the circle that goes through these points F, C, D, E. Okay, that means this is still, we want to prove that this is a tangent. So we want to prove that this is a tangent. And for us to prove that this is a tangent, obviously we need to prove that now that theta is the same as this one here. Okay, or we can prove that that x, remember this is still part of that circle. I think it's more that x actually as I'm looking at it. So I know that that angle is going to be equal to this angle. Then we can say 10 chord theorem. But how do we do it? We know that if this angle, if these two sides are equal, these are equal chords, so they should subtend equal angles. Now we know that we're going to use the angles in the same segment to get to C1, because as much as we showed it, we didn't justify it as yet. And then we're going to use E2 again. We justify that. Then we say these two are equal. And therefore it proves that to be a tangent. Easy stuff. So we're going to say, well, number one, C1 is equal to angle B, which is going to be equal to X. Why? These are angles in the same segment. Right. We can say here also, we know that E1 is going to be equal to angle B. You can say these are angles subtended by equal chords with BA, or was it AB? With AB equal to AE. Sometimes you can say angles opposite equal sides. I'm just trying to show you some variations. But now, what is the conclusion? The conclusion is that C1 is equal to angle E1. If this is the case, we can say therefore AE is a tangent to circle passing through F, C, D, and E. The reason is the converse of the tan chord theorem. Okay, so folks, you will see that in Euclidean geometry, if you don't know the tan chord theorem, and if you don't know it well, you're going to have problems, okay? So you don't want problems, so you want to study this. Of course, statement and the reason, very important. That is also important. Perhaps the conclusion and the reason for the final statement. Easy 4 marks. So this gives us a 9 marks. which could be one of those questions that sometimes follow a theorem, maybe after proving a 10-chord theorem. Because we don't really, in your syllabus, you're not supposed to prove. Hey guys, inanitoli lula lento, yes? Do you know ukuthi all the theorems, including their converses, were examinable? We needed to know all the theorems, their proofs, including the converses. Yes, there were popular questions, of course, but you needed to know, including proofs in trigonometry. The cosine rule, you had to know how to prove it. Sine rule, what is the other one? Area rule. And you also needed to know how to prove the formulae for sequences and series, okay? I think ALES, including the proof for the formulas that you use for an arithmetic, for the sum, geometric, and the sum, all of these things you needed to show how to prove them. Yo guys, Nina, in trigonometry, there were reciprocal functions, sec, cot, cosec. You had to know them, the square identity and its derivatives in terms of sec, cot, and cosec. You don't know much. In fact, you don't do much. And yet, sitting here, isn't it? Guys, this is wrong. You need to be stronger than this. Okay, let's move on, guys. I am not well. Actually, guys, I have a hip problem. I don't know what happened to this hip. It's just biting me. If I don't take painkillers, it's even worse. I cannot breathe. Yeah. Let's go. In the diagram alongside, circle center O passes through F, S, H, and G. Again, what do you know? Concyclic points. So we see a bow tie immediately. We know that G2 is definitely going to be equal to F2. Those are angles in the same segment subtended by chord SH or arc SH. Likewise, H1 is going to be equal to S2. Again, those are angles in the same segment, this time subtended by arc FG. You see, you don't wait, you give it. Now, DF and DS are tangents. If they are tangents, they're going to be equal because tangents from the same point are equal. Then this suggests that we are going to face a silo sakunanzika, as in it's silo shakunanzika. This one, okay, maybe we can say this angle should be equal to that angle. Those are angles opposite equal sides. Seeing those tangents are equal. But then the 10-chord theorem is taking us down this path, that this angle is going to be equal to those two as well. Either we're looking at the tangent DS or tangent DF. Okay. We are doing the things, guys. Remontwing. Remontwing. Then what is the story? Nothing. DF is parallel to FS. Okay, that parallelity we can see. I don't immediately see what it helps me with. Actually, I do. So this immediately changes things around, because now this angle is going to be the same as the other ones. You see, that's why I was hesitating. That when there's these parallelities, it already tells you and I that this angle, if that is the one, it is also equal to that. Why? Those are alternate angles. And then, of course, angles opposite equal sides fits in there, and then the 10-chord theorem fits in there. So there's lots of questions one can create in this question. Okay, it says now FOH intersects SG at R, FOH intersects SG at R. Okay, so this is to suggest that this is a diameter. Because once we name it like this, we mean it. It's a straight line. So if this is a straight line, there's an additional thing is, we know that this angle is going to be a right angle. Right, it's an angle in the semicircle. Okay, that's nice. And also, a tangent is always perpendicular to radius. That's 90 degrees. Okay, so that angle is also 90 degrees. Now with parallel lines, we know that this angle is also going to be 90 degrees, corresponding angles. Or you can say co-interior angles are supplementary, therefore R1 is 90. If we have 90 there, guys, guess what? This is cut into two equal parts. Line from center to, perpendicular to chord will bisect the chord. We are singing theorems here. We are singing theorems. Again, we know that these are ready, so they will be equal. If that's the case, this angle is, whatever that is, this angle will also be equal to that. Again, angles opposite equal sides in that triangle. Yo! So 22.1, let's answer it. It says prove that DSF, where is DSF? There. So there's our triangle DSF, and then OHG. Okay, so that's the triangle, the isosceles triangle. All right, okay, 7 marks. That sounds strange, but we're going to go for it. So in triangle DSF and triangle OHG. So let's see, what is the story in these two triangles? We already saw something. Yeah, we know that we're going to link this angle to that angle as angles in the same segment. Then this one to that as alternate angles. Then we can say that angle is equal to that. Okay. But again, do you see we have that isosceles triangle situation, which irritates me to the core. But anyway, we're going to deal with that. And then again, we're going to say, well, this is equal to that, and that is equal to that. Therefore, these two must be equal to. Then those triangles are similar. It's very nasty. Once you have isosceles triangles, it's not so nice. It's just cumbersome. Anyway, what are we going to start by saying, guys? DSF, ke mang mthwane ke F1. We say handle hore F1 is going to be equal to S2. These are alternate angles with DF parallel to SG. Okay, we can say here also, we know that S2 is itself equal to H1. What is that? This is angles in the same segment. So what does this conclude? It concludes that F1 is equal to H1. Okay, that's the first one. Now we're going to say, but what, sir? We know that essentially, let's start on that one. We know that S3, I drive an S3. Spare that it's broken now. And these guys are not fixing my car fast. I've never spent so long without my car. While it is with the experts. Yo. Hi guys. Just gave me a low oil pressure signal. A whole lot of other issues came after that. These mechanics. And yet you're servicing the car where it should be tested and checked all the time. They don't know it. Okay, S3 is equal to F1. Why? these are angles opposite. Maybe let's not be too hasty. Let's start by saying, but we know that DF is going to be equal to DS. These are tangents from the same point, right? So this implies that S3 is going to be equal to F1, which makes it angles opposite equal sides in triangle DSF. Okay, right. What are we going to say? We are going to say likewise. Eish bafethu, isingesi sivele nje size kamnandi nje. Sithi OH is equal to OG. Why, these are both ready, which implies that essentially OGH is going to be equal to H1, which means these are angles opposite equal sides in triangle OHG. So what can we say here, guys? We can make a conclusion that S3 must be equal to OGH. Okay, you can see that they link to all the the angles we proved equal. As I said, an isosceles triangle makes it so cumbersome. Now we can make a conclusion that, yay, if we prove two sets by fate, where are those two sets? This one. If we prove these two sets, we don't need the third. So this is triangle DSF is similar to triangle OHG. Reason, angle. We did two. It's enough for similarity. Don't even question it. Even if your teacher questions it, say, okay, I understand, teacher. You write it again in the exam. Okay. You're not going to be penalized. But to please your teacher, you might have to write what they say. But look, you don't want to waste time here. Certain things need to be there in your head that, okay, it's there, must I know. Yes, when you practice, you can go all the way to town. But when there's thick traffic in town and you've got to go past town, you look at the shortcuts and the bypassing techniques, Because, I've been to town. Hey, you cannot go to town the same way even when conditions don't allow. Right. Statement, a reason. Statement, a reason. I think this conclusion is important. Statement, a reason. Statement, a reason. Conclusion. 1, 2, 3, 4, 5, 6. And of course, phansi ndaphambana ndashiywa zingqondo sibatlekisiwa ke eng ke kelello monna ke nahana hore jwale e balehile ntho ya teng jwang ke ngotse hantle so 22,2. Let's do this one, the suplex city, but it's supposed to be suplex, but it's not suplexing anybody. It's just, Okay, let's see. DF. Okay, ngwana batho. Kiani. Hatamela mona. Ke bue le wena taba tse monate. Ona le nako manyeo. Ha ke na nako. Man, wena ska tlo nhlantsha man. Ha ko bitsa o tla hona mona ho nna kere. Ska njwetsa ntho tse ngata. Ke batla utlwa ka tsona nna. SF. Okay, SF. Riaobatla. Kiani SF. Okay. Hocho hore re sa bua ka di triangle tsa rona. One, the green triangle is already complete. We don't need the third side. To be convinced we are working there. Okay. FH. Hlahella wena man. FH. Hey. O batla o etsa jwang jwale. Sheba mona man. Ke yona ntwana. Kiani FH. Hey. ka re tlo tšhentšha magiere nthwena, digiere di tšhentšhile jwale. E bapala ka nna jwale. Hai, ha re sa tseba jwale o hlaha kae wena. FH, empa he FH ha re ka e nahana hantle. Hobaneng se ke bona thunyana wa ka mona hore FH is actually twice OH. OH being part of this lovely triangle. So you see, most guys, these things are going to do this thing. We're going to look at that side too and be like, yeah, man. Yeah, you are doing that. And then let's see, HG. You see. We saw you. That we're now Tlobagamo. Hocho is our triangles that we proved similar. Then after that, we're going to play the gymnastics of saying OH is half FH. That's how we're going to bring in this 2 times DF business right there, because half is going to sit here and then cross multiply. DF over. Now DF is opposite that. We said that angle is equal to which one? Yes, it's equal to what the best lingana nape, guys. Lingana nalia angle most. The side opposite is OH. Okay, let's do it. This is equal to, now I already know what I want. I want FS. Yes, they wrote SF over. SF is opposite that one is that, and then HG. Yes. Now we can say similar triangles in 22.1. We are becoming specific people. We cross multiply and solve for DF because we want that DF nicely. So this implies that DF, okay, maybe let's not rush. Let's just say this is going to be DF times HG, which is going to be equal to SF times OH. QOH, isn't it? Now we are going to say, but, in fact, I just want to go for it, guys. DF times HG is equal to SF into this one. OH is half FH. Right? See, it's the diameter, Baba. Can say diameter. Can say radius is equal to half diameter. Hey, see, guys. See, DF times HG is going to be equal to SF times FH over 2. Now we cross multiply the 2 and divide, so we know that 2 times DF is going to be SF times FH over HG. This one, that one. Yeah. There's nothing else left to be done. So easy 10 marks, guys. Smile our way forward. And of course, if you want this document, is going to be in the description, the memorandum, as well as this document here. Okay. So that you guys don't cry and say did not have the materials. I gave you the materials. The materials, question 23. You see, in the diagram alongside 2 circles touch internally at A. They touch there. AB is the diameter of the larger circle. So if it is the diameter, it subtends a right angle. Thank you. AL is the diameter of the smaller circle, so it also subtends a diameter. Now this tells us that this friend is parallel to that friend. Corresponding angles are equal. Now S and L are the center of circles. So it's the contour for this one and the contour for the other. Right. D is a point on the smaller circle and C is a point on the larger circle. Yeah, we see them. ADC is a straight line. We want to hear those news because if not told, we become miserable. So ADC is a straight line. Now, do you see what we've created? A triangle where proportionality theorem applies. But now this is not just the proportionality. Remember, this is the radius, a radius. So this makes it a midpoint theorem. Yo. If this is the midpoint theorem, we can already see that this side must be equal to that side. Why? Because this side is already equal to that diameter. These are both radii bafuets. So sigqibile. Asifuna ukuthetha sesixabene nje kakubi. Ahait. Yo. Ke ngwe taba wa bona le yona yane e etsa ntho tse tshwanang. Midpoint theorem even there. Yo. Now if we get a midpoint theorem, stuff like that, then this line is also parallel to the other three. Yo. I say decorate, I marinate, sazenza zonke. M is a point on LP so that MN is parallel to LC, already indicated. Autis waka uleswa khokaka is 23.1. I'm tired of this anyway. Prove that DL is parallel to CB. Done and dusted. So we know, folks, that angle ADL is going to be equal to 90 degrees. This is the angle, not angles, angle in a semicircle. That's what they say overseas. Semicircle, like no man, it's a semicircle, man. Samasiqhela, man. Sizela amagama inyama yenkomo epikileyo engumtyupa. Ihluzwa ngamanzi ongenamafutha. Siqhela kabi. Masingaqhelwa ke. Beniyiqonda loo nto leyo. The second one, we know that also, guys, ACL, anterior cruciate ligament. Is it ligament? Yeah, the anterior cruciate is also the angle in a semicircle. So what do we know now? We can say, therefore ADL is equal to ACL. So if this is the case, it already confirms that when DL is definitely parallel to CB. Why? Because corresponding angles are equal. ADL and ACL are corresponding angles. So once the corresponding angles are equal, it means the things are equal too. So this one is 1 mark, 1 mark, 1 mark, 1 mark. Crazy. This should be just 3 marks, man. But yeah, we take and go. Aye, man. Yabona. You see this. 23.2. Says prove that 2SDL is equal to LC. What? 2 times SD is equal to LC. Midpoint theorem. Midpoint theorem. But this one is gonna be painful, eh? Yeah, it's gonna be painful, man. It's gonna be painful, this thing. Yikes. How am I gonna plan it? You see, this one cannot be 3 marks. This is the one for 4 marks. The first one is the one for 3 marks. Aye, man. And ngibani lo bhale numbers apha ezosiphambanisa. Hey guys, sendipopeni manje. So iqala kanjani? Hayi. Angisazi ke mina manje. Ukuthi sengizoyithini ke mase inje lento. Hey. 2SD. Why? Hayi bafethu angeke mana nimeni kancane. Ay. AS is equal to SL. These are ready. Ready or not, we know it. Second thing, we know that also. We actually saw that technically AL can be equal to, if English is my English, LB. What is this? These were ready, guys. Now we proved above that DL is parallel to CB. If that is the case, we can say, well, since DL is parallel to CB, proved above, we can make a conclusion that indeed AD must be equal to DC. Right, what is this midpoint theorem? Ngiyayizama. And I think I should have started here actually and brought that one later, but hey, sigqibile na. We are going to say now, we are going to say, therefore, hey guys, namangas. We can say therefore, hey, why 1 and 20? We can say therefore SD must be parallel to LC as well. Akunjeke sithi ke ngoku midpoint theorem nayi. Aye guys, I hate questions like this that are so cumbersome, and yet it's the truth. If this is the story, what knowest thou, guys? We can say therefore SD is going to be half LC, isn't it? Again, same problem, midpoint. And then was in the abuser, so therefore 2 times SD is going to be equal to LC. But this question was so unnecessary though. So unnecessary. It's ridiculous. If anyone submits a question like this, I would throw it in their face. Tell them, what are you thinking? Really? This is not a good exam question at all. Anyway, 3 marks. There's trouble here. I think that one is doing the things, right? Right. I think this conclusion was also pretty important. Without it, we were not going to move forward. Bafethu, angathi. Maske sithi konke nje log 1 mark because kuyafana nje. Just to keep the peace, you see, because I'm already not at peace. But I have to keep the peace, huh? So this is now 23.3. Says determine the value of SL over AB. Siyashaya ke leyo. Funa ukwenzani manje? Funa ukuthini? Suppose SL, okay, masingayithethi into obusibuza ntoni. SL over AB. SL over AB. So this is going to be Hi guys, man, SL over AB, angeke afethu nibhala impendulo. It's 1/2, finish and clear. Enye nenye, hayi andizingeni guys. Nani nizozibonela. Sothini la? Hayi. Radius. Let's do it. Radius is equal to half the diameter. That's why. So SL is the radius, the diameter is that. So injalo afethu. 2 marks. However, this is given. Again, this is a ridiculous question. 23,4 says if AB is 30 units. Okay. Get it. Re tlwaetse jwale ntho e ngata. Okay, 30 and Bn over Nc. Bn over Nc is 7. So this is 7x is to 9x. Please choose a multiple when given the ratios because it doesn't mean those are the units. Determine the length of LM. So we want this guy. Sigqibe lento. Masivele nje sivale lezozo. Thatha isigubhu usifake ezozweni. Ezozweni ufaka ama-specs uzobuzwa. Uzobuzwa ubumnandi obulapho. 3 marks kuphela nje. Sayithathaphi le 3 marks bafethu. Sizoyiplana sithi yabona xa i-diameter ingu-30. This means ngu-15 there because it's a half. That's the diameter. That's the radius. So now we can see, but no man. We don't need to struggle here. We just get nicely into this one. We just slide into these blankets. And we just sleep. A night sweet sleep without any fear of being chowed by the animals outside that are full of danger. Gevaarlijk. Konje animals try in Afrikaans. So we're going to slide into that triangle. Afets kemetsi amanyane ntwena. Nna ke tlo kena ka teng kere. Se ke fihlile. Hey, I had a bad dream, guys. LCB or LBC. Not in LBC, but triangle LBC. I had a very bad dream, But yeah, I'm not going to tell you what it was about. So we know, folks, that LM over the whole side, so velocity LB, the lawyers, is going to be equal to Cn over CB. This is the proportionality theorem. Vit Mn parallel to LC. Aye, simkhayela wena balo LC phaya. Yeah. Sesiyayishaya manje. LM over u-LB siyazi bangu-15 sana. Sizoyichaza nokuyichaza basimthathephi. Sesigrand kakhulu ukuchaza. Cn is ubani wena? 9x over CB. So 7x. Bese sithi wena uyasuka. Now uyasuka. Bese siya cross multiplier wena uye pha. Bese sithi therefore LM is gonna be 9 over 7. 7 phezulu 9 over 7 times 15. Irifa 19 comma tings. Irifa 19,29 units. Remember, usually the general instruction will say 2 or more decimal places. If it says or more, you can do 3. If it says 2 only, you do 2, okay? Or you just round off to the nearest integer. Nobody cares. It's going to be 19. But hey, don't take chances. If you've got decimals, just do it. So statement, reason. This 15 was nice. I don't care to explain anymore. But that calculation, the final answer, guys, that's it. For this lovely question, we take our 6, 9, 12 marks. And we salute you guys and hope that this revision course was doing course things, that you were able to follow and learn as much as you are supposed to learn. If you don't learn, it will learn you, and you will be in trouble, that your future will be stalled. Okay, guys, please practice. I can do a ton of these questions. It doesn't help you. Okay, don't be too used to seeing me do it. But I'm keeping these as some form of reference, because remember, learning, guys, it's a process. You don't just see it once and it's done. Sometimes you need to come back to this video, revisit how I do things to really solidify on some of the mistakes you're making, and you get better and better. Sometimes you come back to just see if you can find other ways of solving the same problems that I have solved. Because remember, I can solve it in one way, but you can even see 2 or 3 other ways in which you can solve the same problem. Please do that. Don't just solve it one way and that's it. When you practice Euclidean geometry, first your target is to be able to answer, okay? So you answer the questions. Once you're finished, you go back and find other ways in which you can answer the same questions. I promise you, that way your mind is going to go wild when you do Euclidean geometry, and that way you will be succeeding in excelling in this question of Euclidean geometry. And you can see the higher order questions are true percussions to your skull. So you really want to learn this, guys, and you want to master it. Otherwise, you will find this lovely memo of ours in the description, together with this question paper. I'm going to make sure, though, that my annotations are gone, so that you can be able to work on these diagrams. You can make as many copies as you want. In fact, I don't want my 23 to go, because I want you guys to know when I say question 23, which question it was. All right, folks, so you know what to do now. You sit down, you practice. Remember, grade 11 theorems are already in your head. If not, go back and check them out. Term 2 is your friend and an enemy if you don't know grade 11 stuff, because look, guys, you're only going to be taught similarity, which is what we worked with, and the proportionality theorem in grade 12. But the examination is going to include grade 11 theorems. So you better know them. And again, I've shown you how to annotate diagrams in the best way. So we've gone through all these Euclidean geometry questions in this high flyer document, from start to finish, okay? Of course, in 2 videos. So I hope you have learned a thing or two. Again, guys, if you are lazy, you're not going to win in this topic. But if you are eager and you have patience and you take your time, you're going to be better at this. Please do not rush doing these questions. If you rush, you are going to go into some serious problems, okay? You're going to run into some serious matata. So you need to take your time. Don't ever attempt to rush this question. Do not. I repeat, never ever attempt to rush this question. It is not a question to be rushed, but a question to be respected. Wangwa. Yeah. Wangwishisha. All right, guys. Now let me give you some tips, if you call these tips. If you want to, someone asked me, how would, or at least what should someone who wants to master maths in grade 12 and to ensure that they get a distinction, what should they do? Well, there's not a lot of things to do, but perhaps a significant amount of work that would have to follow doing certain steps, you know. You know, I used to play, tips, and there was a song by, what is this lady? Leona Lewis. That's the song I actually want to tell you guys that it will get better in time, okay? Yeah, you're gonna go through some bumpy roads first, but yeah, it goes like... Hey! Dilibele! Ay, say more shagel. It's senior heel. Let me put some strings though. I like some strings in this one. Yes. Let's go. Ay, Lilibel. It's been the longest winter without you. I didn't know where to turn to. Yes, somehow I can't forget you. After all that we've been through. That one, guys, basically it's gonna get better in time. This thing is gonna percuss you, but you're not gonna forget it, eh? The percussion that you get, you'll never forget. Okay, now let's get to business and stop the nonsense. Now, folks, question was, how do I pass maths with distinction, and how do I ensure that? Now, there's two things I want to tell you. When it comes to maths, guys, algebra is your first stop. If your algebra is whack, your math is going to be whack, okay? If your algebra is okay, you are only going to pass maths. You are not going to excel in maths, okay? That's the thing. Now, if your algebra is solid, you are a boza when it comes to algebra, then you're going to excel in maths. And you're going to maintain a distinction effortlessly. If you ever put any pressure on yourself, you'll be working towards 100% as you guys somehow get these 100%, okay? So that's the thing. Algebra, guys, needs to be strong. Now, what is the second thing you want to bring close to that algebra? Is functions. If you can master functions like you know your name, you can twist, turn it, stretch it, shrink it, pull it, push it, flip it. If you know those things, I promise you guys, because you will see that in some algebraic expressions, you actually need the aid that is functions to even make sense of the solutions, or at least to get a direction. You know, sometimes in functions, you need an algebraic manipulation to then understand the twists and the turns of a function. So these two are interchangeable. So if you get your functions right, provided your algebra is super, I promise you guys, look where this helps you at. Sequences and series in your paper one is nothing but functions. You've got the arithmetic, which is a straight line function. You've got the quadratic, which is a parabola. You've got the geometric, which is an exponential function. And all of those properties, yes, with some restrictions, but most of the stuff is built like that. Now, this already tells you that your algebra beats two stones. No, two birds with one stone, because you will kick sequences and series, you will kick functions, and of course with some flavors that are mixing up in the middle. Now look what this helps you with again. If you go to financial maths, you will realize that sequences and series are your friend there, especially to look at the timelines, to know the number of payments, because that's usually the problem in that topic. After that, everything is straightforward. Knowing how to use those formulae, but you're essentially dealing with geometric series there. That's all you're dealing with. So just remember that. So again, can you see all of this knowledge makes you comfortable in financial math. You get to differential calculus, you back to algebra again. Algebra, differentiation, using the first principles, simplification. You go to the cubic function, again, the knowledge of functions in relation to algebra, and this time with an addition of differential calculus. You go to optimization, again, you need your algebra, you need your knowledge of functions, then you need this added knowledge of, differential calculus. So do you see, guys, almost 80% of your paper now is comfortable in your head. Then you bring in probability, which is, okay, that topic, yeah, it is what it is. I don't like it, but I know how to deal with it, but I wouldn't claim I would master it all the time, and you can see that it gives goosebumps, especially the counting principle icon. It does things to me. But after all, guys, I've shown you how to survive it. I've given you a nice video, a short course on how to survive probability, whether it's the grade 11, grade 10 type, Venn diagrams, tree diagrams, contingency tables. You have no excuses, because if you know the rules, you know the tools, you are going to be fine. I promise you will ace probability instead of panicking and suffering. And then, of course, guys, a bit of algebra is needed, because with tree diagrams, you will see that sometimes you end up with algebraic expressions to manipulate all the way to the answer. So don't forget, it may come in, especially the higher grade questions on probabilities involving tree diagrams. Then, of course, guys, that is paper one. Do you realize that your algebra alone being good enough will actually make you transcend all those topics of paper one with ease? Go to paper two. Now, paper two, you need to know your Euclidean geometry properly, guys. Because you know what advantage Euclidean geometry provides you? You actually get to master analytical geometry, because you will always see that the higher order questions in analytical geometry link up with Euclidean geometry. And essentially, back in the previous grades, grade 11, grade 10, measurement, don't forget that topic. Again, that measurement topic starts from way back, grade 6, somewhere there, grade 6, grade 5, in fact. From grade 5 upwards, calculating the area of a triangle, you name them, area of a rectangle, and then you come and do all these fancy things. So don't forget that. If you know your Euclidean geometry and your measurement for paper 2, then your analytical geometry becomes a joke. Trigonometry, essentially, guys, it's algebra. Again, you see, that's the biggest section of paper 2. If your algebra is good, your trigonometry is going to be good. You just need to remember laws, and your algebra is your final common pathway to solving problems in trigonometry. And essentially, guys, that's it. Go to statistics. It's nothing but probabilities somewhat. So if you understood probabilities and percentages and all of those chances and what, then you get to analyze now all of those chances, you know, given a certain piece of data. Again, those are easy marks. And you can see, guys, that to square distinction in your time is easier than it ever was before. Yeah, if you guys existed in our time, I can tell you for free, none of you would get a distinction. None of you. Because, yeah, higher grade stuff, guys, it's suffering. It's just suffering. But of course, there were some standard grade questions within the higher grade, as you saw in some of the videos I showed you. But you can almost appreciate that, yeah, you need to be very strong to survive those exams. Anyway, guys, that's how you can nail your mathematics onto the tree or onto the wall and look at it with a very funny, not funny, but with a wide, sly smile of victory. So that's it. So that's the 2 cents, guys, I can share with you on how to nail your maths. And I already did videos on, you know, Euclid, what is this? Algebra, and of course focusing on some higher order questions, because most of you practice all these easy things, basic algebra from grade 10, you know, factorizations and solving quadratic formula, which is grade 11. I mean, we are not impressed. Yes, it's going to come in some way, but I feel manipulations of some serious thought need to be factored in the algebra section. It should be painful, by the way. In fact, algebra should be painful from question 1 to the last in that question, because that's the only thing you've learned the longest in maths in your school career than anything else. Other things have just simply been applications of algebra, and you've seen this throughout the videos I've been doing for you. Okay, guys, let's not talk too much. Good luck, and find those videos. Watch everything I give you. It will benefit you. Do not underestimate anything you see me do. It's going to come to haunt you. I've been saying this to many, and they saw it for themselves. So you don't want to be another one. You don't want to be another statistic of people who have had the privilege of seeing something but chose to ignore it. So become like an obsessed individual, someone with OCD, obsessive compulsive disorder. When you see something, you need to find the compulsion to master it either way. Even if it doesn't benefit you now, it will in the long run. Believe me when I tell you. Yeah, that's it, guys. Goodbye. I'll see you in the next one. Keep practicing.